So we can continue. Now we go to method number 5. Go to rule number 5. Number 5 is called Rapri's rule. Rapri's rule. And in this Rapri's rule, what we do is that we begin here with the option. Then we compute something called simple average payoff. Compute something called simple average payoff. So when we start with P1, the simple average payoff is 15 plus 10 plus 0 plus minus 6 plus 17. All these you divide by 5. We are dividing by 5 because there are 5 outcomes. What's the answer? .2. We go to B2. We have 3 plus 14 plus 8 plus 9 plus 2. We divide by 5. 7.2 again. We have P3. P3 we have 1 plus 5 plus 14 plus 20 plus minus 3. You divide by 5. Hmm? 7.4. You come to P4. We have 7 plus 19 plus 10 plus 2 plus 0. You divide by 5. 7.6. So the advice. So with these Rapri's, with the Rapri's method, we go for the highest average. So the highest is this one. Therefore, you advise that the low average product P4. You advise that the route product P4. The next rule, number 6, is called Howick's rule. Howick's rule. Now this one works with alpha. The examiner here has already guided us that 1 minus alpha is 0.35. 1 minus alpha is 0.35. So we have the option, and then we have something we call weighted average payoff. Now, alpha is a measure of hope. It's a measure of optimism. that you have, that things will work for your good. Anytime you are negotiating with anyone for something, even before you are told yes or no, you are able to start judging that when mambo inaenda, chances are itakubalika ama itakataliwa. Even right now that you are preparing for the exams, you already have started developing an opinion. When ninaona mambo itakuwa namna hii, depending on how now you are judging yourself as we go topic by topic. And this measure of optimism, the highest is 1. The difference, like now this one, 1 minus alpha, is called measure of pessimism. It is the doubt that you have that things will work for your good. So for B1, you take, now that 1 minus alpha is 0.35, alpha then must be 0. If you are told this is 1 minus alpha is 0.35, so alpha must be 0. Now here 6.5, the tunasema is the measure of optimism that things will be good. So you multiply it by the best payoff around that our option, which is 17. Plus this one of things being bad, you multiply the worst case scenario, you multiply by the worst there, which is minus 6. $8.95. B2, we have 0.65. Multiplied by the best there. The best is 14. Plus 0.35 multiplied by the worst. The worst there is 2. 9.8. P3, we have 0.65 multiplied by the best there, the best is 20, plus 0.35 multiplied by the worst. The worst there is minus 3. 11.95. And P4 is 0.65 multiplied by the best there, which is 19, plus 0.35 multiplied by the worst there, which is 0. 13. $12.35. 12.35. Okay. The same thing applies here, that we go for the highest. The highest is this one. So you advise down there that they should round product P4. You advise that they should round product P4. Now, before we do the others two that remain, we will have to prepare something we call the regrets. So this one you have to wait a bit. Regrets stroke opportunity losses table. Opportunity losses table. When someone tells you that they are regretting, what are they telling you? They are not very happy with, not just very happy. There's something they are saying. You know, I may not be happy with you and I don't keep on saying. I may not regret. After making the wrong choice. After failing. After failing, you know, there are some places you fail and it's a place. That's it. Yes, there are places you fail and you say, hey, good. They lost. Yeah, that's a specific one. If you lost, now you cannot celebrate. So if you hear someone saying, I wish I knew, I'm regretting, they are simply telling you they made a choice. That choice made them to fail, and the fail created a loss. And that loss has generated pain. Is why they are now regretting. Now, in simple terms, opportunity losses, also known as regrets, they represent what you have lost for not making the right choice. And the argument goes like this. We say these are outcomes which are unknown. If you had someone to tell you for sure this is how things will be, this is how things will be, then you make the right choice. And now you come here. If the first market condition will be M1, you can round any of these four and get all these. So the best, mtu akikwambia hiyo market itakuwa M1, the best would be this one. So you go for 15. So if 15 inaandikwa hapa, it is the best. Then now you say if for some reasons you went for 15, you got 15. Ukienda kwa P2, you got 3. Ukienda kwa P1, you got 1. P3, P4, you got what? 7. So the argument is like this. You got 15 where you should have gotten 15. So did you lose? No. You got 3 where you should have gotten 12. So you lost what? Sorry. Where you should have gotten 15. So you lost what? 12. You got 1 where you should have gotten 15. So you must have lost. You got 7 in a place you could have gotten 15. So your loss is what? 8. And the probability of that happening is 1. Then when you come to M2, kama ugeambiwa that this is what will happen, ugeendea what? 19. You know, someone who has an advisor, they don't really struggle. They just go for the best. But if you don't have an advisor, you really beat the push before you get somewhere good. So sasa huyu mwenye ana advisor anamwambia ni hapa, they just go pick the best. So if for some reasons you picked 10 here, then you lost what? If you picked 14, you lost 5. If you picked 5, you lost 14. If you picked 19, then you lost nothing. So that is how the table is designed. So you can now. Yeah. So you can design a table now of that nature. So this is 0.4. So as you design now, I continue with the workings. So here the best is 14. We are through. So if we are through, to get the expected opportunity, we shall now come to rule number 7. It's called Minimax. Regrets. So in the Minimax regrets, we have the option, and then we extract the maximum regrets. So P1, P2, P3, and P4. So ukifuata P1, the maximum regret hapo ni 26. Ukifuata P2, the maximum is 15. Ukifuata P3, the maximum is 20. Ukifuata P4, the maximum is 18. So the advice. Now here, when we say minimax, we are talking of selecting the minimum of the maximum regrets. So the minimum of these maximums is 15. So you advise them to round product P2. So that one is first of all identifying where you can suffer. Then you go for the one that you're suffering less. It's the case you hear people saying which one is a lesser devil, one is a lesser evil. Yeah. It's the same thing that people are asking, where are we safe? All those fellows, none of them is very clean, so to put it. So we ask ourselves which one is a little bit better. Good. So the next rule, number 8. Number 8 is called savage. Some people just call it regrets rule. Savage or regrets rule. We have the option here, and then we compute someone known as expected opportunity loss. Expected opportunity loss. So P1 ni kama tu venye tulifanya na EMV. So unachukua hizi payoffs, you multiply by the probabilities. So this will be 0 multiplied by 0.1 plus 9 multiplied by 0.2 plus 14 multiplied by 0.4 plus 26 multiplied by 0.2 plus 0 multiplied by 0.1. Aha, inakuja ngapi? 12.6. We go to P2. P2, it will be 12 times 0.1 plus 5 times 0.2 plus 6 times 0.4 plus 11 times 0.2 plus 15 times 0.1. $9.12. Let's go to P3. 14 multiplied by 0.1. Another 14 multiplied by 0.2. 0 multiplied by 0.4. Another 0 multiplied by 0.2. And 20 multiplied by 0.1. 8.3, yeah? Okay. 8.3. Mm-hmm. 6.2. So do the same for P4. Okay. So you select the minimum. So the minimum of those is 6.2. So the advice that you shall give is that they should round product P3. The minimum is. So those are the 8 rules that you can come across. So the last thing that you need to do with this area is called value of information. value of information. Value of information. So in the value of information is usually given as EMV with information minus the best EMV without information. So what you do, you come back to this original table, this one, and you go picking the best. I told you someone who has information, they pick the best one. So here we have the information, we go for 15 with 0.1 chance. Here we will go for 19 with 0.2 chance. Here we will go for 14 with 0.4 chance. These are the one we have 20 with 0.2, and these are the one we have 17 with 0.1. Those are the best. Then, sorry, those are the one with. Then the best without, the best without is easy to compute, which are 10.4. The best was 10.4. The best kwa hizo EMVs, check whether the answer will be 6.2. So if it is 6.2, that now brings us to the other formula, which you will find in your notes, that value of information, it is the lowest EOL. The lowest expected opportunity loss is also the value of information. I think I told you earlier on, when you are making a decision on how much to pay, you either look at what do I start to gain, or what do I start to lose. Yeah. So that's what guides us in deciding how much to pay. Good. Any question? So on your own now, we will add this question of November 2019. November 2019. Question 5A. Question 5A. You have that. I would suggest that you use that question to do everything that we have done back up for value of information so that you get more familiar with it. Good. You can see we have around 20 something minutes. On Friday, we solved one question at decision tree. So I just need to solve one more. To memorize your decision trees. And the one that I want to solve, we go up April 2022. The paper of April 2022, question 7B. April 2022, question 7B. Read through that question. What is the objective? We are told an investment manager in an investment fund has a choice between one, a diversified portfolio promising 15 million with a probability of that, a risk investment consisting of 2 contracts, construct a decision tree. So this guy, as I told you, we always start with what? With a sketch. So the sketch here is that we are deciding on 2 things, either the diversified or the risk one. Then for each of these, there are 2 possibilities. So that becomes very easy. And therefore, we design here. So this one, we have the payoff. Then here is where I want us to draw the decision tree. And take note of the design. Now these lines, these are complete. The ones are complete. Now let's go. Here kwanza, they are calling it diversified. Diversified. This one is risk. And just use that. So here we are not told the names of these outcomes. We are already told the first one will have 15 million here, and it has a chance of 0.7. So that's the next one will have a chance of rather a return of 8 million with a chance of 0.3. Then this other one will generate 7 million with 0.7 and 3.5 million with a chance of 0.3. A chance of 0.3. So that is the tree. After the tree, I told you we now see computation of EMV at node. Let's start with the node 1. Node 1, they are these, the one we have recorded here. And I told you what you do, unaangalia which lines are going out. If the lines going out are complete, like these ones, those are outcomes. And you just multiply the probabilities, just like what you are doing in the sequence. So you multiply 0.7 times 15 plus 0.3 times 8. And in case, just a minute, in case this line in here, it has a cost. Kama ilikuwa na cost ikiandikwa, sema ilikuwa na cost ya 3, ikiandikwa hivyo. In case it has a cost like that one, you subtract. But now this one does not have a cost. So you just get the answer straight there. $12.9. We come to number 2. Number 2, you do the same thing. 0.7 multiplied by 7 plus 0.3 multiplied by 3.5. $5.95. When you go to number 3, now you can see the lines moving out of number 3, they are incomplete. So if the lines are incomplete, you select. These are now options. Now, some you see those things. So we will take the higher EMV at 1 and 2, because that is where those two lines are going. Zikitoka kwa number 3, zinaenda kwa 1 and 2. So the higher is 12.9. Na hiyo 12.9 imechaguliwa kutoka kwa number 1. So you come and mark here that. That mark means we have selected that. So the advice that you shall give is that they should invest in a diversified portfolio. Invest in a diversified portfolio. Tulisema we are ending at 10 or 10:30. 10:30. Okay. So if it's 10:30, then we can do one more question. This is one of November 2020, question 2A. Otherwise, you already have it. Oh, before we do that, I think a value of information so that I don't forget. Value of information. If they ask you for value of information when you are using a tree, you simply come back here. Naona hii ya mwisho. Unaangalia imeenda wapi. So hii imeenda kwa 1 na 2. Unachukua the highest. Obviously the highest ndio tunatumia ku decide. Then you take the second highest. The difference is the value of information. So that is the highest. The second highest is here. So result of the value of information when you have drawn a tree, that's how it's done. So I'm saying now we look at the question of November 2020, question 2A. Karibu kusoma. So inasema a baker must decide whether to bake brown or white bread. See, those are the options. So we can do together. Look here. So here we are deciding on whether we shall go for white or what? Brown. Demand at the market can either be small or large with a probability. So once you go for whichever, demand can either be small or large. Small or large. With those probabilities. If brown bread is baked and demand proves to be high, the baker may choose not to expand or to expand. So very happens. If the demand is high and we have baked what brown or brown the same as small or large, you may choose to expand or not expand. Follow here first. This is where you get it. You either expand or you don't expand with those pairs. If the brown bread is baked and demand is low, there is no reason to expand. So if demand is small, no expansion. So your answer to it. I'm saying no expansion. If white bread is baked and demand proves to be low, the choice is to do nothing or to stimulate through demand through advertising. So we have baked the white and demand is small. So you have two choices. You can do nothing. You can do nothing or stimulate demand through advertising. You stimulate demand through advertising. And then the response to the advert may be either modest or sizable. So when you place the advert, here, you will either get they're calling it what? Modest or sizable. With the probabilities that if modest, the payoff is like that. If white bread is baked and demand turns out to be high, demand is high, so we are just given that. So that means there is nothing you do. So that's Andrea. It means we have to grow a tree that has 1, 2, 3, 4, 5, 6, 7 tails. You're going to do a tree that has 7 tails. So once you have understood this sketch, it becomes now very easy to do the fair copy. So if you want to do the cascade, you can draw the design the fair copy. 1, 1, 2, 3, 4, 5, 6. Position 3. So hapa ndio tulisema this is white bread. Hapa tukasema ni brown. Demand here can be small or can be large. If demand is small, you do nothing. You do nothing. If you advertise, you make an advert, and the response can be modest or sizable. If you do a brown bread, the demand again is either small or large. Large ndio tulikuwa tunaambiwa hivi na do something. That is for brown bread. Brown bread turns to be brown, proves to be high, or proves to be high. You may choose to expand or not to expand. Okay, so expand. Not expand. Yeah, that's for brown. Alafu, probability of demand being small is 0.3, being large 0.7. Small 0.3, large 0.7. If you have done the brown one and the market is high and you choose not to expand, you get 350,000 not to expand. And if it is, if you expand, you will get 420,000. If you bake the brown and demand is low, there is no reason to expand, you get 310,000. If you bake the white one and it comes out raw, you can do nothing. I think that is a loss. So if you recognize it as a loss, you lose 90,000. Then you stimulate the demand, and the probability of the response being modest is 0.4, being sizable is 0.6. And if it is modest, you get 50,000. Get 50,000. And if it is sizable, it grows to 340,000. If the white bread is baked and the demand turns out to be high, then you have 1,400,000. Yes, we already through. Through. Right? What is it? No. Okay, sure. So let's now compute the earpiece. Computation of EMVs at node, and I want us to be in thousands. And use the figures in thousands. So at node 1, unakuja hapa kuna node 1. Naona the lines going out are complete. So it's a case of multiplying. So that's 0.4 times 50 plus 0.6 times 340. 2 to 4. We go to number 2. When we go to number 2, you see the lines going out are incomplete. So it's a case of selecting. So it is the higher at 1 and nothing. That is how I can put it. At 1, hapa, na here nothing. So 1 iko na 224, nothing iko na minus 20. I mean minus 90. So the higher is 224. Na hiyo yenye umechagua imepatikana kwa number 1. So you should come here and mark that. Twende kwa number 3. Number 3, the lines are complete. So if the lines are complete, you multiply. So it's a case of 0.3 times what we have in number 2. Number 2 tumepata 224 plus 0.7 times what we have in this one of right, which is 1.4, 1400. $1,400. Oh, 10. 2. Okay. Twende kwa number 4. Number 4, you see the lines going out incomplete. So it's a case of selecting. So it is the higher payoff at the end. The higher payoff. So the higher payoff, we will go for 420. Na hiyo tumeichukua hapa, so you mark. Chaguliwa hapo kwa expert. Then twende kwa number 5. Number 5, we will take 0.3 multiplied by 310 here plus 0.7 multiplied by what we have in number 4. Number 4 is 420. Twende kwa number 6. Number 6, now you see it is a case of selecting. So it is the higher at 3 and 5. So 3 iko 10, na iko so it is 1047.2. Na hiyo tumeichagua kwa number 3. So you mark here. So what do you advise? So here we shall advise. Taandika hivi. Walikuwa wameuliza what? Advise on the best product to introduce it to the market. So tutawaambia introduce white bread. Introduce white bread. And if demand turns out to be small, advertise. And if demand turns out to be small, advertise. Kama tungeamua hapa, kama tungewaambia Brown, kama hivyo ingekuwa mzuri, tungewaambia introduce Brown, and if demand turns to be large, you smart. Good. So I'm thinking we can call it a lesson at that juncture. And for your practice, kwanza upambane na hizo tatu. For understand those three. Si tumefanya 3 questions. Kuna ile tulitangulia Friday, kuna hizi mbili. I'm saying that because I keep on telling you the best way to learn mathematics is first of all to do what we have done together and check whether you can be able to produce it that way. So we call it lesson at that point.